So we're going to start today talking about order of operations. That's probably something with which you are somewhat familiar, and it's really important because when we look at something that has more than, at a problem that has more than two steps, we have to know in what order to solve it. For example, if we look at these two problems, there's multiple ways I could solve it. For example, I could say, well, 6 plus 12 is 18, and 18 divided by 3 is 6. That's if I work it left to right. So 18 divided by 3 is 6. Or I could say, well, 6 plus 12 divided by 3. If I did the 12 divided by 3 first, I get 4, and 6 plus 4 is 10. It's really important that we all understand how to do it in order because and that there's a common way that we all do it, because if we all choose to do it our own way, then we're going to end up with different answers. Another example of that, 24 divided by 6 is 4, and 4 times 2 is 8. So doing it that way, we would get 8. But if we did it and we did the 6 times 2 first, then we're going to get 6 times 2 is 12, and 24 divided by 12 is 2. Well, again, it's important that every time we do a computation that there is a common accepted answer to it, because otherwise we can't really do a whole lot with math. So we have to have an understood and accepted way in which to do the problems, and that's where order of operations becomes important. So when we're working with order of operations, first thing I want to talk to you about just for a quick minute is the word evaluate. In the word evaluate, you should hear the smaller word value. And so to evaluate means to find the value of, or in other words, to solve a problem. And there's an accepted order in which to do that. And you probably in elementary school might have learned PEMDAS, please excuse my dear Aunt Sally. And that's great and all, but when you look at that, that looks like there's 6 steps to order of operations. There are not 6 steps to the order of operations. In fact, there are only 4. And so I kind of like this pyramid way of looking at it. When you look at it this way, you can see that there are 4 steps. Let's talk about what they are. So the first step is to do anything that is any kind of grouping symbol. So parentheses or any sort of grouping symbol. And we'll look at some different grouping symbols here in a little bit. And then our second step is to do anything that has an exponent. Our third step is to multiply or divide in order from left to right. This is a Sharkey step, because people often will say, well, multiplication comes before division because the M comes before the D. That's not accurate. You multiply and divide in order from left to right, whichever one comes first. And the same thing with addition and subtraction. We'd add or subtract in order from left to right, whichever comes first. So again, if we look at that in words, we do anything in parentheses, then we simplify any exponents, then we multiply or divide in order from left to right, then we add or subtract in order from left to right. So let's look at some examples. And when we look at these, we're not actually going to solve them. We're just going to talk about sort of the order in which we would solve them. So if you want to, as we're going through these, you can pause and try it yourself and then see if you're right. So when we look at this, are there any grouping symbols? No. Are there any exponents? No. Is there any multiplication or division? Yes. So I have to do that in order from left to right. So the first thing I'm going to do is this division. The second thing would be this multiplication. And the only thing that leaves then is I have an addition to do. Now this problem is getting a little more complicated. I've got several steps here. So the first thing I look for again, and you can do and make yourself that little triangle to remind yourself, parentheses, exponents, multiply or divide, add and subtract. So you can do that if that helps you to keep track of what to do. So do I have any parentheses or grouping symbols? Yes, I do. Right here, the 16 divided by 4 is in parentheses. So that's going to be my first step. Second step, do I have any exponents? Yes, I do. I have that 3 squared. So that's my second step, is to do the 3 to the second power. Do I have any multiplication or division? Yes, I do. In fact, that's all I have left. So going from left to right, it would be step 3 and then step 4. Now this problem has more steps, but it's really not a hard problem. Again, do I have any grouping symbols? If you look through and you ask yourself those steps every single time, it's an organized approach. it'll help you get it in the right order. So do I have any grouping symbols? Yes, the 3 plus 9 is in the grouping symbols. So I'm going to do that first. And then, do I have any exponents? No, I don't see any of those. Do I have any multiplication or division? Yes. I'm going to put those left to right. So this multiplication and then this division are my second and third steps. Then I'm going to do any additions or subtractions from left to right. So this subtraction and then this addition. Ooh, we're getting something a little bit different here because we've got something maybe you haven't seen before. We've got these right here. These are called brackets. And the reason why we have those is they're another type of grouping symbol, but we wouldn't, when you have one set of grouping symbols inside of another one, you use two different kinds of grouping symbols because otherwise it becomes confusing about which is the opening grouping symbol and which is the closing one. So, for example, if it were written like this, it becomes really confusing because we have two opening parentheses and two closing parentheses. And how do you know which one goes with which one? By making them different, you can match up the ones that are the same shape and you know how they go together. So when we look at this set of, or at this problem rather, we definitely have grouping symbols, but there is more than one thing inside of those grouping symbols. So I actually need to then look at all of this together and decide what it is that I'm going to do first. So when I look within those grouping symbols, well, I notice that I actually have another set of grouping symbols inside of that. And that's where the 6 plus 3 squared is. So I have to look inside of that set of grouping symbols because I found a set of grouping symbols, and so I start over and say, well, are there any grouping symbols? Yes, there's a set of grouping symbols inside of that. So now within this inside a set of grouping symbols right here, the 6 plus 3 squared, do I have any more grouping symbols inside of that? No. Do I have any exponents? Yes. So that's my very first step. And then I have to do the addition that's inside of that set of parentheses because then that will solve everything within that inside grouping symbol. So my first thing is the exponent right here. My second thing is going to be this addition. And that would leave me still with the whole grouping symbol not solved because I have to have all of that grouping symbol solved, all of this, before I move on to anything outside of the grouping symbols. So the next thing is going to be actually to deal with this right here. And that, in case you weren't sure, is actually a multiplication. A number next to a parentheses with nothing in between means to multiply. Now that we've completed everything inside of all the grouping symbols, all we're left with is addition and subtraction, so we do that from left to right. Now, these two problems look super, super similar, and unless you're looking carefully, you may not realize that they're not the same. If you look at this, the difference is in the placement of the exponent. The first example has the exponent inside of the parentheses, and the second example has the exponent outside of the parentheses. So when you look at that, that is important in the order. When I look at the first problem and I want to evaluate that, I look for grouping symbols. Do I have any? Yes, I have 8 minus 2 to the second power inside of parentheses. So now I ask myself within that set of parentheses, do I have any more grouping symbols? No, I do not. So do I have any exponents? Yes, I do. That's my first step. Then I have to finish up the parentheses with the only thing that's left, which is the subtraction. Now that I have finished up my grouping symbols, do I have any exponents outside of the grouping symbols? No, I don't. Do I have any multiplication or division? Yes, I do. So that comes next. And then all that I'm left with is this addition. Now, on the second example, it's very similar. I still have grouping symbol, but notice this time within my grouping symbols, I only have the 8 minus 2. So the 8 minus 2 would actually come first. And when I get the answer to that, which is 6, then I would do the exponent because after the grouping symbols are done, then I do the exponents. And so it would be 6 to the second power. Then my last two steps are still going to be the same. Then I would have to divide and finally finish up with this addition. So now that we've had a chance to try some of these out, let's go ahead and to kind of look at some problems, let's go ahead and actually work some out. Again, if you want to pause and try to work them out yourself first and then hit play and see how I've done them, that's totally great. Try it, and then if you got it right, great. And if you made a mistake, you can see where your mistake was. All right, on the first problem, do I have any grouping symbols? Yes, I do. The 10 minus 9, which is 8. Now, here's where some of you aren't going to maybe like to do this, but I'm telling you this is the best, most effective way to work these out. Rewrite the whole problem. Do only one step at a time and rewrite the whole problem after each step. So I have replaced the 10 minus 9 with an 8. So that's now gone, and I need to rewrite everything else. 5 plus 3 to the second power times 6 minus the 8 that I replaced the 10 minus 9 with. So now, do I have any more grouping symbols? No. Do I have any exponents? Yes. I have the 3 to the second power. So that's what I'm going to do next. And if I need a little space over on the side to work, that's fine. 3 to the second power means 3 times 3, which is 9. So that's going to give me 9. And I rewrite 5 plus 9 times 6 minus 8. Do I have any more exponents? No. Do I have multiplication or division? Yes. So this is going to come next. 9 times 6 rather is 54. Copy everything else. 5 plus 54 minus 8. Do I have any more multiplication or division? Nope. All I have left is 5 plus 54, which is 59, and 59 minus 8, which is 51. So my answer to that one is 51. On the next one, 24 divided by 3 times 2. This is a deceptively difficult problem because people so quickly want to do that 3 times 2 because they're thinking PEMDAS, M before D. That's wrong. We don't have any grouping symbols, we don't have any exponents, but we do have multiplication and division. We have to do them left to right. So the 24 divided by 3 is first. That equals 8, and 8 times 2 is 16. Our next example, 62 minus 15 divided by 5 in parentheses, and this means times 4. So let's take a look at this. Do we have any grouping symbols? Yes, we have the 15 divided by 5. 15 divided by 5 is 3, so let's rewrite everything else. 62 minus, notice that my parentheses are gone because I have finished up what's in the parentheses, so I don't really actually need them anymore, but I do need to put a multiplication symbol here because that's what we're doing. A number next to parentheses with nothing in between means to multiply. So when I rewrite this problem, I have to write times 4. Do I have any more grouping symbols? No. Exponents? No. Multiplication or division? Yes. So I'm going to do this multiplication. 3 times 4 is 12. And 62 minus 12 is all I'm left with, and that is 50. All right, let's look at a few more examples. Now we're getting a little more complex into things you may not have seen before. So our first example here, you may not have seen this exact kind of thing before. This is what's called a division bar. And what it means is solve the top, then solve the bottom, and divide those two answers. So really I can kind of work those in the same, work on the top and the bottom at the same time, following order of operations on the top and on the bottom. I can't do anything with the times 5 yet until I solve everything that's involved with the division bar. So I'm just going to recopy it for a while. So 5 times. On the top, the only thing I have to do is 6 times 2. So that's 12. On the bottom, I have something in parentheses. So that's going to come first. 11 minus 9 is 2. And the 2 next to the parentheses right here, this 2, is going to mean 2 times the answer to what's in parentheses. So 2 times 2. Okay, I need to continue solving the what's on the bottom of the division of of the division bar so that I can then get to a point where I can divide. So I've got 5 times, I still have 12 on the top, but on the bottom, 2 times 2 is 4. Now I can go ahead and finish up my division bar. 12 divided by 4 is 3. And so I've got 5 times 3, which is 15. All right, this next one looks like a doozy, but when you take your time and break it down, you're going to be okay with it. So, do I have any grouping symbols? Absolutely, I have grouping symbols. In fact, I have 2 sets of grouping symbols. So, here is my first set of grouping symbols, and here's my second set of grouping symbols. And I actually have one set inside of the other one. So, the set that's inside has to come first, because within the big set of, within the red brackets, I have to follow order of operations. So that means I have to do any parentheses or any grouping symbols inside of that first. So 5 plus 3 is 8. So this leaves me with 6 times 8 plus 12. Again, notice I'm done with the parentheses because I've solved what's in there, but I'm not quite done with those brackets yet. So I have 120 divided by whatever the answer to what's in my brackets would be. So within the brackets, I have still a multiplication and an addition. The multiplication comes before the addition. 6 times 8 is 48. So I end up with 120 divided by 48 plus 12. Finishing up the brackets, 48 plus 12 is 60, and 120 divided by 60 is 2. Now, this again, these two problems look super similar, sort of like some we looked at earlier, but they are not the same because of the placement of the exponent. So let's solve them and see if we get the same answer. On the first example, we do have grouping symbols, so we're going to do the 15 minus 3 first, which is 12. And so we're left with 2 times 12, and that exponent goes with the answer to what's in parentheses. So the exponent goes with the 12. So my next step, do I have any more grouping symbols? No. Do I have any exponents? Yes. I have 12 to the second power. So 12 to the second power means 12 times 12, which is 24. Guess what I just did? I made the same mistake that a lot of you often make, which is really to write and think 12 times 12, but to do 12 times 2. 12 times 12 is 144. And I'm left with 2 times 144. And 2 times 144, I might need to come over here and work out, and that's okay. 2 times 4 is 8, 2 times 4 is 8, and 2 times 1 is 2. So 2 times 144 is 288. So that's the value of that expression. Now let's look at one more. 2 times the difference of 15 and 3 squared. So when I look at this, I have to do grouping symbols first. Well, within my grouping symbols, I have both the subtraction and the exponent. The exponent has to come first. So 3 to the second power is 9, because 3 times 3 is 9. So I have 15 minus 9 in parentheses, and I'm going to have 2 times that. So 15 minus 9 is 6, and 2 times 6 is 12. That's a big, big difference. So notice on the first example, I got 288. On the second example, I got 12. Take a moment now and try these 7 problems. I've given you an answer bank. Try those 7 problems on your own. Pause while you're doing that, and then when you're ready, hit play and see if you have them correct. If you have some that you've missed, go back and look at them and see if you can figure out why you missed them. Again, take a look at your answers. See if you can figure out what you did wrong. Did you make a computational error, or was it an error in order of operations? And so kind of start to look for which types of errors you tend to make. Another thing that's really common is people make mistakes in terms of computation. They make mistakes with exponents. So now we've had a chance to go back and think through order of operations and how we have to do a problem. If you go back and look at our 2 initial problems that we were looking at, you should see that the first one, our correct answer would be the 10 because we had to do the order, we had to do the division before we did the addition. On the second problem, our answer is going to be 2 because again, we have to do or our answer rather is going to be 8. Sorry, our answer is going to be 8 because we have to work at the division and the multiplication from left to right. So that one is going to give us the answer of 8. And if we didn't have a standard way that we all did the problem, then we would end up getting different answers, and that would be totally confusing.